Hello, AWE. It is so great to be here. Finally back. Even since last year, we've seen tremendous advances in artificial intelligence. And as these AI models become more capable, the way we interact with them evolves as well. Voice is becoming the primary interface for AI, and smart glasses are at a unique position. They're in the forefront of this paradigm shift. For decades, we have an interesting relationship with technology, and it always revolved around screens. We would get a notification, we would stop, we would bring out the phone, we would look at it, and our attention was gone. We can do better than that. The next generation of AI experiences is going to be more ambient, conversational, and more importantly, the technology is going to be slowly disappearing. And this is why smart glasses are so compelling. They provide you seamless access to, They provide you seamless access to information, conversation, AI assistance without you looking down. So, how do we make this happen? That's what we'll talk about today. We'll talk about the underlying technologies, we'll talk about the engineering challenges, and the processing architectures. The good news is that NXP has created a complete, low-power voice audio solution specifically designed for the rigorous wearables environment. And here, to talk a little bit more about that, is Laurent Pilati, our in-house audiophile.
Thanks, Nick. Thanks, great to be here. Smart glasses occupy a unique position among wearable devices. Unlike headphones or watches, they sit directly in our daily experience of the world, so they are deeply personal devices. They influence how you see the world, but they influence also how the world sees you, and that's why design matters. But for engineers, every millimeter matters. Every microphone placement matters, and every milliwatt matters. And while AI plays a critical role, there is no practical smart glasses without AI at the edge. So to create this invisible AI assistant, we'll need voice interaction, and we'll need augmented audio, which is superposed to the world without masking it. So what does it take to have this invisible AI assistant? First, one of the biggest shifts we are seeing in the technology, this is a transition from search to conversation. Historically, we interacted with computers by typing commands, entering keywords. Today, we are increasingly using conversation. Instead of searching for information, we ask questions. Instead of navigating through links, we are having a conversation. And this shift is happening on consumer devices, enterprise applications, and AI assistants. And as these interactions become more conversational, users expect change as well. They expect AI to respond naturally. They expect AI to understand the context. And that's what I would like to explore next. But first, if we want to make AI feel like human conversation, we need to understand what makes human conversation feels natural. And interestingly, it's not just about words. Human conversations are full of subtle signals. And two of the most important are the back-channeling and the barging. The back-channeling is to show how we are an active listener. All those answers like, yeah, I see, amazing, they're just here to encourage the conversation, say, yeah, I like it, keep going. And on the other end, you have the barging, which is equally important. The barging allows people to, at their point, clarify a point or steer the conversation in a new direction. And in real life, we don't expect for the perfect turn. We want to interact, we want to collaborate in this discussion. So if AI assistants are going to feel like a true conversational partner, they need to support the same behavior. And that turns out to be much harder than it sounds. Typically, in this case, in the first case, the perfect echo canceller will have to go through the whole amazing without any specific answers. Those does not expect any answers. But on the other hand, tell me in Fahrenheit, suddenly the AI assistant needs to stop in the middle of a sentence, but not in the middle of the word, change the unit and continue the conversation. And if we look closely to the human conversation, we discover something very surprising. Human conversation operates in a fast pace. Typically, after this presentation, I hope someone will invite me for a drink. And if you say, okay, Laurent, when you go for a drink? Oh, yeah, for sure. My answer can happen in less than 50 milliseconds. Natural expectation is around 200 milliseconds between the question and the answers. But by the time it reaches 600 milliseconds, people will notice the delay, and the conversation will feel less fluid. And the good latency often makes the difference between a natural conversation and the one that feels artificial. And for smart glasses, every millisecond matters, because if the system responds too slowly, users will stop treating like a true conversation, but more like talking to a machine. And the challenge is that conversational AI involves far more than one single device. In fact, conversational AI, it's a cascaded system. It starts with the AR/VR devices, where you capture the audio, you process locally the audio, and you send wirelessly up to the AI cloud. The AI services will send back the answers up to the ears of the users. So individually, those small blocks may be very small delay, but all together, they may significantly impact the user experience. So you need to optimize each of these pipelines. At NXP, we believe the foundation of the conversational AI are based on three main pillars. First, whatever are the number of CPU, DSP, you need to have ultra-low latency pipeline to meet human expectation. Second, you need to support the barging, the backness channeling. Users should be able to interrupt the AI and the AI to respond accordingly. And third, you will need a perfect echo cancellation and noise reduction. Remember, design matters. For smart glasses, loudspeaker and microphone are close together. And without proper echo cancellation, the AI assistant may start to hearing himself and have his own conversation. That's not what we want. So let's look at the technology that makes this possible, starting how smart glasses can hear the speech in real world. Because so far, we assume that we can hear the user clearly, but that's not always easy. Smart glasses operate in a noisy environment, like this AW conference. So the first challenge is to capture the wearer voice and remove the background noise. For that, we use a fixed beamformer. This is like a zoom lens, but for the sound. So instead of capturing equally the audio, we can focus in one direction, so in this case, the mouth of the wearer, and we can extract the speech. The result is that better speech quality for voice call and better voice recognition. But conversation involves far more than just capturing the wearer. In many situations, smart glasses will need to understand someone else. Think about a live translation or just talking to a friend in a bar. And this is where comes into play the adaptive beamformer. The adaptive beamformer will capture the important speech in your environment. And as people are moving, it will prioritize the most important speech in the environment. So the fixed beamformer for the wearer, the adaptive beamformer for the bystander, all together, they create a complete acoustic scene environment for the conversational AI. And ultimately, the beamformer is not just about audio quality. It's about helping AI to understand what people are actually saying. And we measure that through the word error rate. The word error rate tells us how often the speech recognition misunderstands words. And speech recognition errors increase with the noise. And what we show here is that our attention front end, which is composed of the beamformer and some AI processing, in some challenging noise situation, can reduce those errors by up to 4x. The result is that the AI understands more what you say, even in challenging environments. But another way to evaluate the performance is by looking at the signal-to-noise ratio, the SNR. This tells us how good or how well you can separate the speech from the noise. Those smart glasses operate in noisy environment. The attention front end will capture the speech while removing the noise. And the gain we show here is not just that the AI is hearing more, is that the AI understands more. And that's critical for wearable AI devices. So up to this point, we discussed about AEC, the echo cancellation for the barging, the back channeling, the beamformer to capture the speech. But at NXP, we developed an entire voice and audio solution. First, because we want to make sure that all these individual blocks, all together, they work efficiently. And second, most important, this allows our customer to focus on creating use case differentiation rather than solving fundamental audio processing challenges. But capturing the speech, being the wearer or the bystander, is only half of the equation. The other half, which is equally important, is how do you play back the audio back to the users? And this is where audio playback becomes critical. And one of the reality for smart glasses is that users expect an experience similar to much bigger audio devices. They expect speech to be good and music to be loud and clear. The challenge, of course, here is physics. Remember, design matters. Speakers inside smart glasses are extremely small. They are constrained by size, by design, by power. And as loudspeakers become smaller, they are more susceptible to distort. So here, to create premium audio, it will require much more than increasing the volume. It will require an intelligent system that can constantly adapt to the audio based on the constraint of the small loudspeaker or smart glasses. And this is where our audio enhancement playback comes into play. At NXP, we address this challenge through our essential audio processing, or EAP. And the goal is straightforward. Deliver the best audio experience from a speaker that is operating in a very tight physical constraints. So what EAP does, it continuously analyzes the audio signal and in real time adapt to reduce the stress of the loudspeaker, like mechanical stress and thermal stress. And we preserve the audio quality and we maximize the loudness. So for the users, that means better call quality and better AI responses. But of course, delivering all this voice and audio processing creates another challenge. How do we provide all these capabilities while maintaining battery life the user expects from a wearable devices? And that's where hardware comes into play. To deliver a great smart glasses, you don't just need voice and audio algorithm. You need a complete hardware system with an architecture capable of running those algorithms efficiently. And one of the challenges for those wearable devices is balancing between intelligence and battery life. Users expect always-on assistant, immediate responses, but they also want all-day battery life. And those requirements can often be in conflict. At NXP, we have designed the i.MX RT700 family to address this challenge. The architecture is composed of digital signal processing, neural processing unit, and iCompute, all in separate power domains. The result is that most of the always-on voice can run in low power domain, which means you keep the rest of the system in the low power state. The advantage is that you can build richer applications for developers while extending the battery life, which is one of the most important KPI for wearable devices. And once you have solved your architecture, you can start solving one of the most real-world challenging problems for wearables. Because up until now, what we have discussed is about all these algorithms, but users don't expect algorithms. They experience the outcomes. And one of the most common frustration in wearable audio devices is the wind noise. Anyone who has taken a phone call with a friend in a windy environment knows how frustrating can be such phone call. The wind noise will overwhelm the microphone, saturate the microphone, intelligibility will decrease, and the conversation will be frustrating for both parties. To address this challenge, at NXP, we retune, we revalidate again with our wind tunnel. You see here the AI noise reduction. And the result, we can preserve the speech while removing the wind noise, just because the real world is windy. The result is a much more comfortable conversation. And while this may seem to be like a small feature, there is a broader philosophy. The goal is not simply to demonstrate AI. The goal is to use AI to remove friction from everyday experiences. Which brings us to a much bigger picture. Because everything we've discussed today, the beamformer, the echo cancellation, low latency, they exist only for one reason: to create experiences that feel natural, intuitive, and effortless. So let's step back from the technology for a moment. Let's talk about what all this ultimately enables. Because none of those technologies are the end goal. The real goal is much bigger. It's about changing how people interact with technology. For decades, we had adapted ourselves to the computers. We learned the commands, we learned where to click, what to type, how to navigate on those increasingly complex systems. But now, for the first time, the technology is beginning to adapt to us, because voice is the natural interface. Voice is the interface. And when voice, context, intelligence comes together, something interesting happens. The technology begins to disappear, and the interaction becomes more natural, less than operating a device, but more operating with a true companion. And that's why smart glasses are so compelling. They represent one of the first platforms where AI can be continuously available without demanding our constant attention. And while we are still early in that journey, the foundation at NXP are already built today. So what does the future look like when technology truly becomes part of our everyday lives?
Well, that's a great question. And to help with that answer, we are happy to introduce a special guest tonight, Google's Brian Vogelsang.
Thank you so much, Nick and Laurent, for having me. Again, my name is Brian Vogelsang with the Google product management team. At Google I/O last month, we shared more about our intelligent eyewear. These are glasses that deliver help in the moment without taking you out of it. And these glasses are designed to be a private interface to Gemini throughout your day, offering helpful spoken assistance right in your ear. And that's where we teamed up with NXP. So we successfully integrated Conversa to enable the Gemini experience, while the EAP delivered a critical boost to both audio clarity and to loudness. And this has been a true partnership from day one, and we're really excited to continue building the future together with NXP. Thank you.
We could not agree more. And thank you, everyone. Thank you, Brian. Thank you, Laurent. Have a great show.
Thanks.